Welcome back to the channel. So today in this video we are going to attempt the question number 5, 6 and 7 of chapter Trigonometric Functions of class 11th, exercise 3.1 of CBSE Mathematics. So question number 5 is, in a circle of diameter 40 centimeter, the length of a chord is 20 centimeter. Find the length of minor arc of the chord. So this is question number 5. Here we are given diameter equal to 40 centimeter. So radius will be equal to 40 over 2. That will be equal to 20 centimeter. Now suppose this is our circle and it is having a center O, and this is the chord which is of length 20 centimeter. Let us name this as AB. Now let us join the ends of this chord to the center. Here OA is the radius, so it will be 20 centimeters, as radius of the circle is 20 centimeters. And OB is also the radius of the circle, so this will also be equal to 20 centimeter. Observe that all sides of triangle OAB are equal, so triangle OAB is an equilateral triangle. So here length of chord, that is AB, is equal to radius of the circle, that is OA is equal to OB. So therefore triangle OAB is an equilateral triangle. We know that each angle of an equilateral triangle is 60 degrees. So angle O will also be 60 degrees. Now here we'll have to find the length of this very arc, that is arc AB. So now theta is 60 degree. This in radian measure will be equal to pi over 180, as we know, into degree measure, that is 60 degree. 0 and 0 goes away. 6 times 3 is 18. So in radian measure, 60 degree will be equal to pi over 3. This is our theta. Radius of circle, as we know, is 20 centimeter. Now we'll have to find length of arc. From the relation theta is equal to L over R, we'll be having L is equal to R times theta, and this will be equal to 20 times pi over 3, and that will be equal to 20 pi over 3 centimeters. Therefore length of arc is equal to 20 pi over 3 centimeters. Towards question number 6. Question number 6 is, if in two circles arcs of the same length subtend angles 60 degree and 75 degree at the center, find the ratio of their radii. So this is question number 6. So here we are given with two circles where the arcs are of same lengths. Let length of each arc be L centimeters. That is L1 is equal to L2 is equal to L. So L1 represents the arc length of a circle, L2 represents the arc length of second circle, and these both lengths are equal, and we have assumed that these lengths are equal to L. Now here theta 1 is equal to 60 degrees. Now let us convert this very angle in radian measure. As we know that radian measure is equal to pi over 180 times degree measure. So in radian measure, 60 degree will be equal to pi over 180 degree into degree measure, that is 60 degree, and this will be equal to pi over 3 radians. And this is our theta 1 in terms of radians. Similarly, theta 2 is the angle subtended at the center by arc of second circle. It is equal to 75 degree. Now in radian measure, again it will be equal to pi over 180 times 75. This will be equal to 5 pi over 12 radians, and this will be our theta 2. Now we know that theta is equal to L over R. In terms of R, this will be equal to L over theta. So now ratio of radii will be equal to R1 is to R2, that is same as R1 over R2. Now from this relation we'll be having R1 equal to L over theta 1 whole divided by L over theta 2. Now this will be equal to L over theta 1 times theta 2 over L. L and L goes away. This will be equal to theta 2 over theta 1. Now we know what theta 2 is. Theta 2 is 5 pi over 12 and theta 1 is pi over 3. Now this one solving will be equal to 5 pi over 12 times 3 over pi. Here pi and pi again goes away. 3 times 4 is 12, which means that R1 over R2 becomes equal to 5 over 4, or we can say that R1 is to R2 is equal to 5 is to 4. So this is the ratio of the radii. Towards question number 7. This is question number 7. Question number 7 states, find the angle in radian through which a pendulum swings if its length is 75 centimeter and the tip describes an arc of length. Part first is 10 centimeter, part second is 15 centimeter and part third is 21 centimeter. Now here we are given with a pendulum which swings through some angle. So now this is some arc. It is having different length in different parts. The length of string of this pendulum is 75 centimeter, which will be taken as radius of this arc. Now we'll have to find this angle in radian measure in each part. So here in this case, the length of pendulum, which will be taken as radius, is equal to 75 centimeter in all three cases. In part number first, we have the length of arc is 10 centimeter. That is this very much. Now we'll have to find theta in this case. That is the angle through which the pendulum swings. We know that theta is equal to L over R. So here in this case, L is 10 centimeter and R is 75 centimeter. This will be 5 times 2 is 10, 5 times 15 is 75. So this will be equal to 2 over 15 radians. Similarly, in part second, we have L equal to 15 centimeter. Here again, theta will be equal to L over R. That is equal to 15 over 75. This will be equal to 1 over 5 radians. And last part, that is part third, we are having L is equal to 21 centimeter. Therefore, theta will be equal to L over R, that's equal to 21 over 75. And this will be equal to 3 times 7 and 3 times 25. So this will be equal to 7 over 25 radians. Hope this makes sense. Do subscribe to the channel for more such content and thanks for watching.